Okay, so this lecture is going to talk about hypothesis testing, and specifically type 1 and type 2 errors with regard to hypothesis testing. So the learning goals for this is we're going to define and then apply each of these types of errors. And they're both very distinct types of errors, and they have their own problems that come with them. And so when we're conducting research, and you remember from the last lecture that when we reject the null hypothesis, right, we're basically saying that we're rejecting it based on this critical value of p less than 0.05, right? So meaning that the mean has a probability of 95% or greater of being true. Well, there's some error that comes with this, and that's why we try to be conservative with it. And one research study doesn't tell the picture of everything, and so we need to conduct multiple research studies to identify the same phenomenon. So, type 1 error in this case is when researchers incorrectly reject the null hypothesis. So this happens when researchers conduct a study and they find a significant mean difference between their sample and the population, and say that their sample is significantly different because of whatever treatment, because of some treatment that they're going through or whatever, and so they're rejecting the null hypothesis, but the rejection of and they're accepting the research hypothesis. Where type 1 error occurs is when researchers incorrectly make that assumption. So it's rejecting the null when the null is actually true. So even though the data show a significant difference between the groups, there's actually not a significant difference for some reason. And that reason is usually due to poor sampling. So an example here is that the sample that they collected is naturally better in whatever than the population, or naturally has a higher occurring mean because of their nature, not because of anything you did, right? And so I'll give an example of this. So let's say, Dr. Collin, I wanted to know whether my online lectures would increase my students' finals grades, right? And so I conducted research around this that was presented in the previous lecture. And I found that my students' grades were significantly higher than the UW population of statistics students. Okay, so that's a fair assumption. And so what I did is I rejected the null that my students' finals grades were weren't different, So I accepted the research hypothesis that my students' grades were significantly different. And this is based on the idea that my online lectures contributed to this. However, in this case, type 1 error is occurring, and it's occurring because it's not my online lectures that make my students' grades better. It's actually the fact that my students are just better students, right? And so, using the example of my classroom, or the sample of my classroom, that is just simply a poor sample because the class itself just happens to be better at statistics. And so naturally their grades on finals exams are going to be better, right? So it's not because of the online lectures, but it's because of something else. So this is an idea of poor sampling that's coming through. And so this is an example of a type 1 error. Type 2 errors, on the other hand, this occurs when researchers incorrectly accept the null hypothesis. So they accept the null hypothesis when the null hypothesis is false. Or, if you flip it around, they reject the research hypothesis when the research hypothesis is true. And this is oftentimes due to inadequate sampling. So there is an effect, but the sample size is so small that the effects cannot be detected. So it doesn't look like there's a significant difference. It doesn't meet that critical value of 1.65 a z-score of 1.65. Oh, that's weird. Well, I didn't mean to do that. Anyway, so let's go through this. So again, I want to know whether my online lectures would increase my students' final grades. And in this case, let's say my research found that my students' grades were not significantly higher than the University of Washington Bothell population. So I accepted the null hypothesis that my students' final grades weren't different. And in this case, I rejected the research hypothesis, right? But however, here, the type 2 error, in this case, we have a type 2 error because my students' grades were better than the University of Washington Bothell students on average, but there's not a large enough sample size to really detect that effect. And so when we're talking about power and we're talking about sampling, the larger the sample size that you get, the more power you're going to have to be able to detect smaller differences in populations, in scores across populations. And so just to summarize real quick, and this is a nice little table to have and put in your notes. And so when you make the decision to reject the null hypothesis, a type 1 error occurs when the null is true. So you've rejected the null, but the null happens to be true. And you've flipped that thinking too. It means you accept the research hypothesis when the research hypothesis is false, right? So you can flip that around because they're opposites. On the other hand, a type 2 error occurs when researchers accept the null hypothesis, but the null hypothesis happens to be false. And again, that usually occurs around sampling size and not having enough power. And when I say power, that means statistical power in your sample size to identify effects. So again, the larger your sample size, the more able you are to detect smaller effects. So from this lecture, you should be able to take away the difference between a type 1 and a type 2 error and when these errors occur.